delta such that this part, I really want to know that this part is small. So such that t to k, c d t h, so h to t is less than how much? tk, yeah, 1/2. That's okay. That's always possible, yeah. Because d is some fixed number, and this is at t equals 0, it becomes 0. So it's near to the t equals 0. This number is always.
What's the relation between t and delta?
Yeah.
What is the relation between t and
T and what?
delta?
Delta. Oh, sorry.
Yes.
Such that if t is less for theta. That's okay. Now,
Sorry, but I can't follow the argument. Where does the t come from?
oh, just instead of z, I just to use z equal dt, only that's one direction.
Then what's the point of d?
What's the point of d? D is I want to simplify this part. 1 plus b absolute value of fc. To prove that, I introduce this polynomials, just fc plus z over fc. Then the constant term is 1. And I choose the smallest term, whether a positive term, tk. And then the rest you can write in this way. And hz is has a property that h0 equals 0. This is very important. Okay. Okay. Now, what I want to prove is now what this polynomial there exists some complex number such that its absolute value of g of a is less than 1. So to prove that, so you use this expression. So gz has this form. So maybe I write again. What you can do is first choose the exist d and c such that case file of d is minus 1 over p. There is such one, complex numbers. Then now I restrict this variable d of dt such that t is not this way. Okay? Maybe it's good to have t here. And then g dt becomes here is a 1, and then d k becomes d to k to t to k, and dk is this is minus 1 tk over b, and there's a b, so this becomes tk. Okay? And then here dk actually t is always non-negative, and h dt. Or it's better to write this way. And now I'm interested in this part. Anyway, this is a fixed one. This is one number B. Another point is h dt is continuous. Function at 0. So this means there exists delta such that if t is delta, then dk of h is okay. Oh, you can't see. Sorry. Yeah, it's about this. Okay. Now, if we choose a delta, then again use this inequality. Now consider here delta. Now this is always less than 1, so. And here, this part is. So maybe to write this part. Then this is 1 minus. Okay. And this is strictly this. Yeah. Therefore, you can find that any such dt. Inside of this choose A, then C plus A is, yeah, and then therefore you can find this A such that this is 1, yeah? And then coming back this, the A is so this means that f c plus a c. So this is just a simple. Okay. So this is a. Now this implies fundamental theorem of algebra. Why? We already know that if you consider infimum of the normal, or in a sense, absolute value of fz on the complex plane has its minimum always at some point. Okay. So now choose C such that infimum of fz or whole complex plane is attained by fc. Okay? And assume not zero. Then, from I prove already, they exist, and the C prime, Fc prime, is strictly less than Fc. But this is contradiction, because this is the infimum. Therefore, this is Fc prime. Yeah? So the only possibility is, so this is contradiction, So only possibility is FC should be 0. Therefore, we can find the 0 of the polynomial. So this is the argument proof. So what he really uses is the property of continuous function, and also especially that the continuous function on the compact set attains its minimum value. That is completely non-trivial. So this is the proof. And there are several proofs of the fundamental theorem of algebra, and later, if you talk about the complex function theory, I will give them another proof. There are many, many interesting proofs. And of course, there is a more, in a sense, quite geometric proof or explanation why that fundamental theorem holds is following. That's also the geometry of the functions. So let's consider our polynomial started from Tn. And I want to compare this polynomial with Gn. And the point is, if and I like this. Then that if you can find certain fc equals 0, it's equivalent that you can find h of what? So that means that if you, instead of looking at fz, you can also, it's enough to consider h w. That change the coordinate variable w to z, and then you know that this coefficient is, you can choose L actually large, so that the absolute value of this coefficient becomes smaller and smaller. So in that way, that you can always reduce a problem of the fundamental theorem of algebra in such a way that this coefficient, absolute value of these coefficients are very small enough. And then what happens? So we already know that. Just now consider the complex plane again. And here we have some disk. Yeah. And if consider that just Gz is G to N, this mapping, what happens? So you already know that if complex number is given in this way, then G to N goes to N. And so this means that if this is this part is this is L, so this is a circle of radius L. Then if you apply this one, then that maps to the circle of